Hello everyone. Today I want to look at some of the component creation features of Flowcode version 9. If I create a new project and I click on templates, then you can see that there's a few sections to give various starter projects, but one of them is component creation. So under here we have finished components. And you see we've got a few component source files. So if I say go into the circular buffer and click new circular buffer embedded project, then this opens up the actual source code for the circular buffer component. So you can see exactly how it's been put together and all the various macros that have been used. So if I open up a Project Explorer window and a component properties window, you can see all the properties that have been made. You can see the macros that are here. You can see the events that have been added. So just a simulation start, an add variable and a get variable size. And we can go through each macro and we can have a look how the component source has been put together. If I go back and go new project, templates, component creation, then we've also got comms examples. So you can see that we've got some starting points for making various components using I2C, SPI or UARTs. So if I look at the I2C demo, and load up a new project with that, then you can see that in my properties window I have all of the various properties for I2C communications, including the remap pins, the channel and the mode, whether it be a master or a slave. If you wanted this not to be available for a user, then you could always either right click it and edit, and so you could always right click it and delete and just get rid of it, and then it's not available for the user anymore. It's still fixed, and you can always go in and select the cal I2C if you ever need to change that setting. It's just not available to the user. So where the panel is, these are everything that the user will see, and you can see if you go in, then these are the properties of the actual I2C underlying component. So other things we've got here are things like the simulate comms. So when this is set to no, normally we do some sort of panel simulation, and when it's set to yes, we use the methods like the scope traces on the data recorder window. We have console data in a tab on the console, and we have an injector that you can pass data through to real world hardware or other simulation components. Under the macros, again we've got some events. So we've got an initialize and property event. And what do they do? Well, the initialize will be called when the component is first loaded onto the panel by the user, or when they're loading their project. And the property event will be called whenever any of the component properties are changed. So here you can see it basically shows or hides this comms simulation folder depending on the state of this property variable. We also have a few macros. We have an initialize function, which just basically calls the cal I2C master init. We have a simulation override for this function, which basically all it does is it has a decision. If we're simulating comms, then call the normal embedded initialize function. Otherwise, we can do our own simulation code here. The way the simulation override works is in File, Export, Configuration, and then if I click on Interface, you can see that the initialize macro is here. It's a downloadable macro, but if we're simulating it, then we actually call instead the initialize sim macro. So this is the embedded one that gets downloaded to our hardware, and this is the one that overrides it for the simulation. And you can see the same happens for the read register and the write register. We have simulation overrides. So by default that would just look like this. It would just contain the same name as the function, and we're just adding sim to the end to force it to use this version for the simulation. So the read register is a very generic means of reading an I2C register. This will actually work on a lot of different I2C devices. Not all of them, but quite a good selection of devices, and obviously you can tweak it to work with any of the other devices that might return, say, a 16-bit value rather than an 8-bit value. The simulation version of, again, we check to see if we're simulating comms. If we are, then we call the embedded version. If we're not, then we can do something else here, maybe to do with panel components. Similarly for write register, again this should work on a lot of different I2C devices, not all of them, but a good selection. And again the simulation override does a similar thing, where we call the function itself if we're simulating the comms, or we do something with the panel. I hope this has been useful. I've been Ben Rowland. This has been Flowcode version 9.